Hello and welcome to a video on derivatives. In this video, we are going to discuss about the introduction to derivatives. Okay, so we'll talk about the definition and then finding derivatives using the definition. So let's go back and talk about what we did at the beginning of this course. So we started with the average velocity and instantaneous velocity, and then we were able to approximate or estimate the instantaneous velocity using the average velocity. But we said that that's not very efficient way to find the instantaneous velocity or the slope of the tangent line because we didn't get exact value. We are just approximating. And then we said that, okay, let's hold on to this one. Let's build up some concepts so that we can find the exact slope of the tangent line or exact rate of change at a point on a function. And then we talked so much about limit. Now what we are going to do is we'll use that concept of limit, and then we are going to find the exact slope of the tangent line at a curve or the exact rate of change at a point on the curve. Okay, so now this was one of the definitions that we started with. The slope of the tangent line to the graph of f of x at x equals a is given by either this one or this one. We use this one, but the way that we use this one was not with the limit. We just pick some h, very small h, and then we plug it in. We got some number, and then we approximate it. Now, instead of doing that, what we are going to do is we are going to use this definition. We are going to use this limit, and then we'll find the exact value. So instead of picking up some h, we'll just say h approaches 0, and we'll evaluate this limit. And that gives us the slope of the tangent line at a given point. So let's go ahead and do that. So let's look at the example. I think I pick up the same example that we did at the beginning in our first section of limit. So where we talk about the tangent and velocity problem. So we are going to do the same problem here. Remember, we approximated the slope of the tangent line when we did that section, but now we are going to find the exact using limit. Okay, so here our function is 2x squared, and then we are going to find the slope of the tangent line to the graph of f at x equals 1. Or if we look over here in this formula, a is 1. Okay, so the first thing that we are going to do here is, so we are going to write that formula. So the slope of the tangent line is given by this limit as h approaches 0 of f of a plus h, which means f of 1 plus h minus f of a, which means f of 1, divided by h. Okay, now what we need to do is we need to find f of 1 plus h, and let's go ahead and do that. So f of 1 plus h is, our function is 2x squared, so it is 2 times 1 plus h squared. And let's go ahead and find that. So 2 times, this is 1 plus 2h plus h squared, which gives us 2 plus 4h plus 2h squared. So that is f of 1 plus h. And the next thing that we need to find is f of 1. So f of 1 equals 2 times 1 is squared, which is 2. Now let's bring them back here and then put it into our formula here. So this equals limit as h approaches 0, f of 1 plus h is 2 plus 4h plus 2h squared minus f of 1 is 2 divided by h. Now, limit as h approaches 0, so we can simplify this one because this 2 minus 2 is 0, and then we can factor out h from the numerator. So if we factor out h, we have 4 plus 2h divided by h, and then we can cancel out this now, and that gives us limit h approaches 0, 4 plus 2h. Now we can find the limit by direct substitution, and when we do that, we get this equals 4. That means the slope of the tangent line is 4. See, we got exact. We don't have to approximate anything here. We didn't get 3.999 and we didn't make a guess to saying that, oh, the slope is 4. Instead of that, we got the exact slope. Now, this is the slope of the tangent line. So that is part A of the question. Now, part B says find the equation of the tangent line. Now, we have this slope m equals 4. Now, we need a point to find the equation of the tangent line. So our point is the x value is 1 and the y value is 2. So we are going to find the equation of the tangent line at 1, 2. So we can just use the point slope form here. So we can write y minus y1 equals m times x minus x1. If you want, you can also use the slope intercept form of the equation. Now this is y minus y1 is 2 equals m is 4 times x minus x1 is 1. And then this gives us y minus 2 equals 4x minus 4. And then if we add 2 on both sides, we get y equals 4x minus 2. And this is the equation of the tangent line. Now we are going to look at a very important thing in calculus, okay, the derivative, okay. So if we go back here, let's talk about this one. So here we were asked to find the slope of the tangent line at x equals 1. We were able to use this formula and we got the exact slope. Now, if you're asked to find the slope of the tangent line at x equals 2, then you have to redo all of this math again to find the slope at x equals 2. And if you're asked to find the slope at x equals 5, again, you have to redo all of this math and then find the slope at x equals 5. So every time you are given x, you need to redo this math again and again to get the slope at each point. So instead of doing that, what we are going to do next is we are going to find a function that represents the slope of the tangent line on any given curve. Okay, so if f of x is a given function, given curve, then we have a new function which is called the derivative of f of x and represented by f prime of x, and that equals this limit right here. What does this function do is this is a new function that represents the rate of change or the slope on the graph of f of x. So if I want to find the slope at a point, what I do is I just take that x value, plug it into my new function, which is the derivative of f, and then I get the slope. So if I want to find the slope at another point, I just take that x value, plug it into my derivative, and then I get a slope. So basically this derivative is same thing that we discussed in the previous example, but instead of finding the slope at specific point, the derivative is going to give us a function which we can use to find the slope at any point on that curve. Okay, so that's what derivative means. Now, so there's some notation for derivative. We write f prime x, or if you write the function y equals something, you can also write y prime, okay? Or if you write the function y equals something, you can also write dy over dx, or we also write d over dx of f of x, or d sub x of x. Okay, so usually these are the one that we see here. Okay, f prime x, y prime, dy over dx. These are the very common notation that we are going to use in this course, or wherever you use this derivative. Okay. Um, and then if we are finding the derivative of a function, that's the notation. But if we are evaluating the derivative at particular point, then we do f prime is just like evaluating a function, or y prime of a, or dy over dx at x equals a, wherever you're finding the derivative. Okay. Similarly, we can use this notation or this notation. So again, we'll commonly use these first three notation. Now let's go ahead and do the same problem. I have the same problem. Now instead of finding the slope at x equals 1 directly, what I'm going to do is I'm going to find the derivative of this function. Again, derivative of that function is another function which gives us the rate of change on any point on the graph of that function. Okay, that's all that derivative is going to do. So let's use the definition of derivative, which is right here. to find the derivative of this function. So f of x equals 2x squared. Now in order to find the derivative, we need to find f of x plus h. And let's go ahead and do that. F of x plus h equals 2 times x plus h squared, which is 2 times x squared plus 2xh plus h squared. And then when we distribute that 2, we get 2x squared plus 4xh plus 2h squared. Now we have f of x, we have f of x plus h, and then h is just h. Now we can find the derivative of this function, f prime x, okay, equals limit as h approaches 0, f of x plus h minus f of x over h. So that's the definition. Now let's plug in those values, okay, so limit h approaches 0, so f of x plus h is this expression right here. So 2x squared plus 4xh plus 2h squared minus f of x is this function 2x squared divided by h. Now that gives us limit h approaches 0. So if we add 2x squared and minus negative 2x squared, we get 0. Now we can factor h from these two terms. If I factor out h, I have 4x plus 2h divided by h. And then we can go ahead and cancel these two. So that way we get this equals limit h approaches 0 of 4x plus 2h. Now we can do the direct substitution. If we do that, we get 4x. That means f prime of x equals 4x. Now this is a new function. Now what does this function represent? It represents the slope on the curve of this function. Now the second question, the second part of that question is asking us to find the slope of the tangent line. So this is part A. For B, we need to find the equation of the tangent line, not the slope. So in order to find the equation of the tangent line, we need the slope. So let's go ahead and find the slope. So slope is given by slope of the tangent line at x equals 1 is given by, okay, is f prime of 1. So that means we'll take 1 and we'll just plug it in here, or we'll evaluate the derivative at 1, which is 4 times 1, and that gives us 4. See, that's the slope that we had here. In the first example, it's the same example. So slope was 4, and we got the same thing here. Now what this does is, now if I want to find the slope at x equals 2, I'll just take 2 and plug it in here. The slope is 8. Or if I want to find the slope at 0, I'll just plug it in here. The slope is 0. Or if I want to find the slope at x equals negative 2, then I'll just plug it in here, and then I get 4 times negative 2, which is negative 8. Now, once you have this function, you can find slope at any point you want, okay? So that's what this function derivative does, okay? So now we have the slope. The point is 1 comma 2, and the equation of the line is same as the previous one. Now we already found that, so I'm just going to write it, which is y equals 4x minus 2. We already got that in the previous example, okay? So that's how we can find the exact slope of the tangent line using the derivative. Now let's go ahead and find the derivative of this function and then equation of the tangent line. So the function that we have here is y equals, or f of x equals square root of x. So now this is the part A says find compute dy over dx, or find the derivative. So dy over dx equals, so the definition is limit as x approaches 0 of f of x plus h minus f of x divided by h. Now this equals limit h approaches 0. So f of x plus h is, we just substitute x with x plus h. So it is square root of x plus h minus f of x is square root of x divided by h. Now we know that we have done this type of limit, so we have a radical. So if we plug in h equals 0, we get 0 in the denominator. Then that means we are going to multiply by the conjugate here. So we are going to multiply by the conjugate of this numerator, which is square root of x plus h plus square root of x divided by square root of x plus h plus square root of x. Now, when we do the multiplication, limit h approaches 0. So when we multiply, remember when we multiply the conjugate, if we do a plus b times a minus b, we get a squared minus b squared. So square root of x plus h is squared is just x plus h minus square root of x squared is just x divided by h. Now, and then times, sorry, we are missing this factor. So h times square root of x plus h plus square root of x. Now in the numerator, when we add x and negative x, so that's 0. So we have limit as h approaches 0 of h divided by h times square root of x plus h plus square root of x. Now we can cancel out h and h, and then we have 1 over this quantity here. Now we can plug h equals 0 in here to find this limit. So if we do that, we get 1 over, so when I plug in h equals 0, I get a square root of x plus the square root of x, and that gives us 1 over 2 square root of x. So that is the derivative dy over dx for the given function, which is square root of x. So the derivative of square root of x is 1 over 2 square root of x. Now the part 2 of that question is find the equation of the tangent line to the graph of f at 9, 3. So first, in order to find the equation of the tangent line, what we need to do is we need to find the slope. So the slope is given by, so we are finding slope at x equals 9. So the slope m is given by dy over dx at x equals 9, which is, we'll just take 9 and plug it in here. So 1 over 2 times the square root of 9, and that gives us 1 over square root of 9 is 3 times 2 is 6. So the slope of the tangent line at x equals 9, or at that point 9 comma 3, is 1/6. Now we have this slope here, okay? And then we have the point which is 9 comma 3. Now we can find the equation of the tangent line. So the equation of the tangent line at 9 comma 3 is y minus y1, which is 3, equals m, which is 1/6, times x minus x1. Okay, and then y minus 3 equals 1/6 x minus 3 half when you multiply by 1/6. Now if you add 3 on both sides, so you get y equals 1/6 x. So 3 negative 3 half plus 3 equals 9 half. And that is the equation of the tangent line to the given curve at the given point. Now let's look at another example here. So it says find the derivative of f of x equals 1 over x. And again, we are going to do exact same thing. We'll use the definition, which is right here. So the derivative, which is f prime of x equals limit as h approaches 0, f of x plus h minus f of x divided by h. Now limit h approaches 0. So f of x plus h is 1 over x plus h, because f of x is 1 over x. Now if you're finding f of x plus h, so it's 1 over x plus h, minus f of x is 1 over x, everything divided by h. So this looks a little bit complicated fraction. So this is what I'm going to do here. So limit h approaches 0. I'll just factor out this h from the bottom, and then I'll write 1 over h here. And then I'll simplify this 1 over x plus h minus 1 over x, okay? Now this gives me limit as h approaches 0, 1 over h, and then Let's go ahead and simplify this fraction. We can make common denominator, or we can just do the butterfly math, which is x times 1 is x minus h divided by x times x plus h. So if you make the common denominator and do the subtraction, so that's what you are going to get. So this equals limit h approaches 0, 1 over h. Then in the numerator, you have x minus x, which is 0, then minus h. So this is times, we have negative h divided by x times x plus h. Now what we can do here is we can cancel out this h and this h. So that means this gives us limit as h approaches 0, negative 1 over x times x plus h. And then if we plug in 0, then we get, sorry, if we plug in 0, then we get negative 1 over, so h is 0, so we get x squared in the bottom. So that means the derivative of 1 over x, or f prime of x, equals negative 1 over x squared. Now, if we have to find the slope of tangent line at some point for this function, okay, we can just use this function. So we'll just plug in whatever x, whatever we want to find the slope, we'll plug in that x value and we'll get the slope. So for example, if you are finding the slope at x equals 1, then we just plug it in and then we get negative 1. Let's do this another example. So we are going to find the derivative of 1 over x squared, okay? And again, we are going to use the same definition here. So find the derivative of h of x equals 1 over x squared, or h prime x equals limit. So this h and the h that we are going to use here is not same. This is just the notation for the function, okay? So limit h approaches 0, h of x plus h minus h of x divided by h. Again, the h notation for the function, and then the other h is not same, okay? So now limit h approaches 0. So h of x plus 1 is 1 over x plus h squared, because we are going to replace x with x plus h, minus h of x is 1 over x squared, and then we divide everything by h. Now I'm going to do the same thing that I did for the previous example. So I'll factor that 1 from the denominator out. So limit h approaches 0. So I'll write 1 over h, and then I'll do the other simplification. Okay, so the other simplification is x squared minus x plus h squared divided by x squared times x plus h squared. Now let's go ahead and simplify this. So limit h approaches 0, 1 over h. Now this is x squared minus, so if you expand this one, so you're going to get x squared plus 2xh plus h squared divided by x squared times x plus h squared. We don't have to expand the denominator. Let's leave it that way, and then let's see what happens at the end, okay? So limit h approaches 0, 1 over h, x squared minus x squared plus 2xh plus h, sorry, I forgot to distribute the negative. So here we get x squared, then minus, so when you distribute the negative, so you get x squared minus 2xh minus h squared, everything divided by x squared times x plus h squared. Now in the numerator, I think we can simplify some of this. So x squared and x squared, they add to 0. So what we can do is we can factor out h, okay? So we have limit h approaches 0, 1 over h times. So if you factor out h from the numerator, so we get h out, and then we have negative 2x minus h over x squared times x plus h squared. Now what we can do here is we can cancel this out, and then we can plug in h equals 0. Okay, we can do direct substitution now because we are not going to get 0 in the denominator. So when I plug in h equals 0, then we get negative 2x in the numerator divided by, this is 0, so we get x to the 4th. That means this is going to be -2 over x cubed. So that means the derivative of 1 over x squared, okay, is -2 over x cubed. So h prime x for this one is -2 over x cubed. So it does not look like that. -2 over x cubed. Now there's a theorem which says if f is differentiable at x equals a, then f is also continuous at x equals a. Or if f is not continuous at x equals a, then f is not differentiable at x equals a. This just means continuity is a necessary condition for differentiability. Okay, so if a function is differentiable, then it must be continuous at the given value. But it is not a sufficient condition. So if a function is continuous, we cannot say it is differentiable. But if it is differentiable, then it must be continuous. That's all this theorem says. Okay. Now there are few points, at least these three, where the function is where the function is not differentiable, or we cannot find the derivative of function at some special points here. Okay. So f of x is not differentiable at x equals a if f has a corner at x equals a. If there is a sharp turning point, sharp corner like this one in the absolute value function. So we cannot find the derivative of this function at this point, at this corner. The reason is, remember, the derivative represents the slope of the tangent line. Okay. One thing is we can draw numerous tangent line at this corner. There's no any unique tangent line. Or so if we approach this point from the right, we have a positive slope. Now if we approach to this point from the left, the tangent has a negative slope. So when we approach to that point from two different directions, the slope is not same. One slope is positive, the other one is negative, or they're different slope. Okay, that is why the derivative does not exist, or we cannot find the derivative at that point. The other point is if f is not continuous at a, as we said earlier, continuity is a necessary condition for differentiability. So here, if f of x is not continuous at a, then the derivative does not exist, or we cannot differentiate the function at x equals a, just like this one. So here is not continuous, there is a jump, so we cannot find the derivative at x equals -2 in this case. The third one is f of x, if the tangent is vertical tangent at x equals a. So for example, at this point here, the tangent is a vertical tangent, okay? So we cannot find the derivative of the function at that point, because remember that the slope of the vertical tangent, or the slope of the vertical line, is undefined. That means the derivative is undefined at this point. We cannot find the derivative because the tangent line is vertical, which basically means the slope is undefined. If the line is vertical, then the slope is undefined. That means derivative is undefined. We'll just do this much for this video. So we got the basic definition and basic concept of derivative. Now starting next video, we'll learn how to find derivative, okay? So we did this here, we found the derivative using this definition, but this is again too much work. Calculus is a subject that makes things easier. It's the math that makes things easy, okay? So this is too much, so many steps here. So in order to find derivative, what are some easy way to do? Another thing is that if I give you f of x equals, for example, x to the 10th, and if you have to use the definition to find derivative, then you'll have limit h approaches 0, f of x plus h minus f of x over h. And then if you put it in here with that function, now you get f of x plus h means x plus h to the 10th power minus x to the 10th power over h. Now how do you expand this one? It's really complicated. And if you have a power of 100 or 500, then how do you evaluate this? So using definition, that becomes so much challenging here, okay? So now what we need to do is in next few videos, we are going to learn different techniques to find the derivative, a shorter way, shorter formulas. We'll have some formulas so that we can compute the derivative of this type of function easily in 1 or 2 steps. So that's our plan for the next few videos. For this video, we'll just do this much. I'll see you again.